Chapter 5 is all about the properties of triangles, so let's review some of those concepts. We talked about the circumcenter, incenter, centroid, and orthocenter. Here we're talking about the centroid. The centroid is the one that had the ratio of 2/3. So it is 2/3 of the length from the vertex to the centroid. So if I know that SR is 33, so this entire thing is 33, VR is going to be 2/3 of that length. So I just need to find 2/3 of 33. So 2/3 times 33, or 1/3 of 33 would be 11. So 2 of those would be 22. So the length of VR is 22. Here H is the incenter. We're looking to name two segments of equal length. The incenter is equidistant to the sides. So any of these where I'm going from the incenter to the side, so from H to a side, so HE, HF, and HD, all of those are going to be equal in length. So any two of those three would be correct. We talked about when you have the angle bisector and you find a point on that angle bisector, it is going to be the same distance to either side of the angle. So if I know that this is the angle bisector, MO is the angle bisector, then I know that the 4x minus 5 is equal to 23. This was in one of the sections earlier on. We talked about if these two things are equal, then these two things are equal. This is one of those situations. So we're going to add 5. We're going to get 4x equals 28, and so divide by 4 to get 7. So x would equal 7 there. Here we have the perpendicular bisector. Any point on the perpendicular bisector is going to be the same distance to either end of the segment. So if this is another one of those, if these two things are equal, then these two. So A to this point on the perpendicular bisector is also going to be 22. We talked about various types of triangles, special right triangles of 45, 45, 90, and 30, 60, 90. This is a 45, 45, 90. I know that because of these two sides. If those two sides are equal, the opposite angles are equal, and so these are going to be 45 degrees. Both legs are going to be the same, so if this is 2, B is going to equal 2 as well. And then to get from one of the sides to the hypotenuse, we are multiplying by the square root of 2. So A is going to be 2 times the square root of 2. Here's a 30, 60, 90 triangle. For this, we're always aiming to get back to the short side. So the short side is the one opposite the 30-degree angle. Here I have the hypotenuse. To get back to that short side, going from the short side to the hypotenuse, your factor is always 2. If I'm going from the hypotenuse back to the short side, I'm dividing by 2. If I were going from the short side to the hypotenuse, I would multiply by 2. So 14 divided by 2 is going to be 7. Once I have that short leg, then I can get the longer leg here by multiplying by the square root of 3. So I'm going to end up with 7 times the square root of 3 for that other leg. Here we're talking about the sides of a triangle and can it form a triangle. When we have the 3 sides, any 2 of those need to be larger than the third side. So if I do 8 plus 4, that needs to be larger than 6, which it is. 4 plus 6 needs to be larger than 8, which it is. And 8 plus 6 needs to be larger than 4, which it is. So because it worked for all 3 combinations there, this is a triangle. Now that we know it is a triangle, we can determine if it is acute, right, or obtuse by comparing c squared to our a squared plus b squared. The c is always going to be your largest side, so in our case here, the c is going to be the 8 So I'm comparing 8 squared to 4 squared plus 6 squared. So 4 squared, that's going to be 16, plus 6 squared is 36. So 16 plus 36, that's going to give me 52. I am comparing that to 8 squared, which is 64. So 64 is larger than 52. So my c squared is larger than the a squared plus b squared, which means that it is obtuse. You are comparing your c squared. If c squared is less than your a squared plus b squared, then it's going to be a cube. If it is equal, then it's a right. Or if c squared is larger than the a squared plus b squared, it is going to be an obtuse triangle. When ordering the sides from shortest to longest, we're looking for the smallest angle and going from there. So the smallest angle is the 35. You look at the side that is across from that, that's going to be HJ. So HJ is the shortest side. 45 would be my next biggest angle, so we go across from that. That's going to be JG. And then, of course, the last side that we have here is HG. It is across from the largest angle. With the triangle inequalities, we have CAB and DAB. We're comparing these two angles. We have two sides of the triangle that are the same. We have the 9s, and then they share a side here. So 2 of the 3 sides are the same. It's this third side that is different. So if I'm looking at CAB, the side that's across from that angle is the 5.3. The side across from the DAB is 5.1. So I'm comparing those two side lengths to then compare these two angles. So 5.3 is larger than 5.1, so that means that angle CAB is going to be larger than angle DAB. So larger side, larger angle once again. And then we looked at the triangle mid-segment as well. So triangle mid-segment is going to be connecting the midpoint of one side to the midpoint of the other side. And it is going to be half of the length of the third side. So if I double the mid-segment, that gives me my side length. So I need to double my mid-segment. So double the 2x minus 4, and that will be equal to 3x plus 2. So when I double that, I'm going to have 4x minus 8, make sure you're distributing there, equals 3x plus 2. I could add 8 now to both sides. So that I have 4x equals 3x plus 10. So if I subtract 3x, that's going to leave me with x equals 10. And I could go back and plug this in then to double check, make sure everything's okay. So 2 times 10 would be 20, minus 4 would be 16 for the mid-segment. And then the side length here, we would have 3 times 10, which is 30, plus 2, which is 32. 16 is half of 32, so that's good. Everything is checking out okay there. Remember also with the triangle mid-segment, it is parallel to the side of the triangle. So you end up with things like corresponding angles, or you can end up with alternate interior angles if you are dealing with multiple mid-segments here. So you're going to have some congruent angles as well. The Pythagorean theorem, just to review real quick, is a squared plus b squared equals c squared. Just remember, if it's a right triangle, that's where this is going to work. If you're trying to determine if something is a Pythagorean triple, so here we have 7, 9, and 13. If I plug those in to the Pythagorean theorem, they should work if it is a Pythagorean triple. So a Pythagorean triple are just 3 whole numbers that work in the Pythagorean theorem. So here we have 7 squared would be 49, 9 squared is 81, and 13 squared is 169. So what we need to verify is, does 49 plus 81 equal 169? No, it does not. So this is not a Pythagorean triple. So Pythagorean triple, once again, is just 3 whole numbers that work in the Pythagorean theorem. Okay. So those are some of the concepts we learned about triangles in Chapter 5. Make sure you're familiar with each of those.